So here we go for the second part of question 20 in the June 2017 paper 2, foundation paper. We did first one and we worked out from question 20 that Ollie went at an average speed of 57.1 kilometres from Liverpool to Sheffield. Then it says Janie drove from Barnsley to York. Jane's average speed from Barnsley to Leeds was 80 kilometres. Okay, so it's similar question again. So what I'm going to do just above here is go from Barnsley to York, and then from York, and then we've got to Leeds here. So let's just look at this question. James' average speed from Barnsley to Leeds. Oh, I see. So me dyslexic. You have to go through Leeds. There we go. So we're going from Barnsley to York. Read the question first. Jamie's average speed from Barnsley to Leeds was 80 kilometres per hour. And then her average speed from Leeds to York was 60 kilometres per hour. And the question then says, Janie says that the average speed from Barnsley to York can be found by working out the mean of those two. If Jane is correct, what does this tell you about the two parts of Jane's journey? Well, let's just think about this. If Barnsley to Leeds was 10 times longer than Leeds to York, then she's travelling very quickly, because that's 10 lots of 80 kilometres per hour compared to 60. If Barnsley to Leeds were next door and were only 5 yards away, but this was 1,700 miles, then it's not going to be the same either. So this only works if they are the same distance apart. So the answer is there. Only works, so it tells us, if it's true, that they have the same distance apart. They have the same distance between each place. And that's the only way that would work. Right, let's go to question 21. Wow. Okay, angles and parallel lines, I imagine. So if it's parallel lines, I'm thinking of A to Z, FC, and co-interior C angles. Co-interior. So I'm thinking of these things. As soon as I see parallel lines, I'm putting my mind into that. I'm also thinking of 180 degrees, straight lines. I'm thinking of all these sort of things in my head as I'm looking at this sort of question. So what it says here is ABC, and EDC are straight lines. EA is parallel to DB, and we can see that there. Now it says EC, now I'm going to write this on, EC, E to C, right, that total distance is 8 from there to there, 8.1 centimetres. DC, is 5.4, so I can work out what that must be. Let's just quickly do that. So what I'm going to do is literally use my calculator and go 8.1 minus 5.4 equals 2.7. Oh, and I can see a relationship between 2.7 and 5.4. Okay. And dB is 2.6. Work out the length of this one. Scale factor. So scale factor is new over old. That's how we work out what scale factor is. And I need to know, what do I do? What is my new? What is my old? Well, AE is my new, because that's already given. So I'm going from there to there. So the answer is going to be bigger. And it's like saying I went from 5.4 to 8.5. That's my connection. Okay, so my scale factor is, my new one is 8.1 and my old one was 5.4. So on my calculator, what I do is I do 8.1 divided by 5.4, and I come out as 1.5. So my scale factor is 1.5. So all I now need to do is times dB by 1.5, and I get 3.9, it should be. There you go. So my answer to the length of AE is 3.9. Now the question says, and I'll read out the question so you can hear it, but I'll keep that there. AC is 6.15 centimetres. So A to C, this total distance here is 6.15 centimetres. And I really like drawing on the paper because it makes me feel confident that I'm in the question, and that's quite good. Work out the length. Okay, I want to work out this one here. Now, if I know the total distance is 6.15 and I want to work out that one, the way to do this is to say, well, look at this. This one here, there's a relationship here between this length and this length. And I wonder if you can spot what that relationship is like. Okay, I wonder if you can spot what the relationship is like. Now, I want to go from, if I had this 8.1 and I wanted that length there, you can see hopefully what the relationship is like. I could actually draw a line like that, and you can see that if this is a scale factor of 1.5, then it's a half times more than this. So I've split that in a half and then add it there. I can see I've got actually 3 parts, 1, 2, 3 of equal distance. So therefore I've got 3 parts here as well. So to answer this question, what I do is I say it's 6.15 divided by 3, because that tells me what that little distance is up there. So 6.15 divided by 3. I've done it a slightly different way than, I mean, there's lots of ways of doing this, of course, but I just thought this is quite a nice way of understanding it. And there you go. So that's a nice way of doing it. Now let's go to the next page.